Hi everyone, in this video I'm going to talk about several important concepts in general chemistry, and these concepts are molarity, let's write them down, and solution stoichiometry, and I think that's the two concepts that I want to focus on. And the other one is ion concentrations. It kind of relates to molarity, but let's write down ion concentrations. The most important thing that we have to start with is the concept of the mole. So in chemistry, a mole quantity is a quantity equivalent to, so 1 mole quantity is equivalent to a huge number, which we call Avogadro's number, of particles. Now, the definition of particles is either molecules or ions or formula units. Formula units refer to ionic compounds. Ions, of course, refer to ions, and molecules refer to covalently bonded compounds. And you can also use the mole concept for atoms as well, individual atomic particles as well. So it's important that you remember this number. 6.022 times 10 to the 23 count is 1 mole count. So essentially what I want you to remember is that 1 mole is equivalent to this many counts. And let's say that right now I'm putting these lumps of particles as drawings onto this pad. And imagine that every one circle represents 1 mole. So you're dealing with, in one circle, when I say 1 mole, it's like a huge count of these particles, way too many that I could ever put down. But this one lump of particle is 1 mole. So in this particular example, with this many lumps, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's just make it round and make it to 10 moles. So altogether we have 10 moles. 10 moles of anything. Now I'm going to draw a flask because we're going to be transferring these 10 moles into a flask. So let's go ahead, and I have already a flask drawing here. So let's say that I want to take this 10 mole and transfer it to this flask. Oops. So we have essentially 10 of these particles into the flask. In chemistry, when we are transferring these particles, we often weigh them. So if you're dealing with a solid, weight or mass of the solid is the most convenient way to weigh these particles. And in order to find out how many grams of these particles, we need to have a mass to mole conversion. In other words, 1 mole of these particles would weigh how many grams of these particles. And you can put in, where I put the dotted lines, you could put molecules, ions, you could put formula units and atoms. And so what we do is we refer to the periodic table, and we typically take our molar masses. So this important terminology of molar mass is essentially mass in grams per 1 mole of substance. So we use the molar masses and we weigh the substance, and the weight of the substance correlates to so many moles of the substance. So let's go ahead and use an example here to make it clear for you. So let's say that I am dealing with 10 moles of copper sulfate pentahydrate. So copper sulfate pentahydrate is a solid, and that's how one form of the copper compound or copper sulfate compound is the pentahydrate form. Penta is 5 water. These water molecules are incorporated into the crystal structure of copper sulfate. So it's not a slushy copper sulfate sample, it's perfectly solid, and the water is in the solid state as well. And that's how the chemical comes. So we have to figure out the mass that represents the 10 mole. So please take out your calculators, and I want you guys to do this with me. So I have a periodic table in front of you. I'm going to get my table in front of me too. And let's add up the molar masses of copper sulfate pentahydrate. So we have one copper atom in the substance at a molar mass of 63.55. So we have 63.55 plus one sulfur atom at a molar mass of 32.07 plus 4 oxygen atoms. 4 times molar mass of oxygen is 16.00. That gives me 64 molar mass. Plus the easiest way is 5 times the water. Each water is 18.016. So we can sum this up. Or you could just do plus 10 hydrogens, 10 times 1.008 plus 5 oxygens at 5 times 16. You're going to get the same results either way. So let's calculate that. Please calculate this with me. And you are also going to be double checking my calculation. 249.7 grams per mole. So my copper sulfate pentahydrate has a molar mass of 249.7 grams per mole. So if I want 10 moles of it, how many grams of copper sulfate pentahydrate would that correlate to? So you have 10 mole, and the molar mass is 249.7 grams per mole. And this gives me 10 times 249.7, which would be 2497. Because I'm sticking to 2 sig fig precision here, this rounds to 2500 grams of copper sulfate pentahydrate. Now, let's say I'm using large quantities, but don't worry about the quantities. And let's just say my flask is also large too. So I'm going to transfer this quantity onto my flask. So let's put the flask back here, and we're going to pour this substance of 2500 grams. We're going to pour it into the flask. So imagine that this is a huge flask. Let's say this flask is equivalent to, let's say, I don't know, 5 liters. So let's put 5.0 liters. So this is the label on the flask, and this is the volume of 5 liter that's shown on the flask. And let's say there's no more graduations. So we have to transfer all of the solid. As you transfer your solid, the solid fills the flask. This is your copper sulfate pentahydrate. Let's write it down. And when you make these solutions in lab, of course, you won't be making such large quantities, but you want to make sure that you transfer every bit of solid into the flask. There's a technique you have to follow. And then you're going to add water. So after you transfer, you're going to fill this with water. So essentially we have our, remember this is 10 moles. We have our 10 moles filled into the flask. So I'm going to pick a blue color because the copper sulfate pentahydrate has a very beautiful blue color. that would fill this flask. So now, I'm adding water, but once you dissolve this into the water, the color will be blue. So your flask is going to have 10 mole of this substance, and this is a solution that we just prepared. And what we just did is we prepared a certain concentration. So the meaning of concentration is quantity of solute, which is the copper sulfate, over quantity of solution. Let's abbreviate it as SLN. So concentration means how much of solute do you have in a certain quantity. This is very similar to, let's say that you drive your car at a speed, you drive a distance of, let's say, 15 miles, and you cover that distance in, let's say, 25 minutes. So now you have a relationship of distance over time. So if you were to divide your miles per minute, per the time of minute, you're going to get a quantity that's called speed. So 15 divided by 25 is equivalent to 0.6 miles. Let's put 0.60 miles for every minute. So rather than saying that you cover 15 miles in 25 minutes, we typically go with 0.6 miles for every 1 minute. So that becomes your speed. Well, with the concentration, we have the same concept. The quantity of the solute is 10 moles, and the quantity of solution is 5 liters. Remember, we filled it up to the 5 liter mark, so we have 5 liters. So 10 divided by 5 is 2.0. So this is 2.0 moles per liter of concentration. So this is a quick way to refer to the strength of the solution. The chemical strength is the number of particles that are dissolved in here, and these particles are those lumps of moles that I showed you earlier, and there are 10 of these lumps. Every mole count is Avogadro's number of formula units in this case. So I don't know, I think I put too many. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got carried away. Anyway, let's just make it correct and put 10 of them. So there would be, put the flask back on. So there would be, I think, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 of these particles, or 10 of these lumped particles, and the rest is water. And these particles go into the water, they dissolve away, and it creates a solution of 2 molar concentration. Let's write the chemical equation for what we just did. So the way we write this is, I stress that to my students. Copper sulfate pentahydrate is a soluble salt. You should know your solubility rules so that you can write these equations. So it dissolves in water at the quantities that I have given you. And of course, there's a limit that we call saturation limit, beyond which it would not dissolve, but we are below saturation limit. So we write it as copper sulfate, aqueous. Aqueous means dissolved in water. And for the sake of balancing our reaction, we put 5 waters. This water is going to join to the rest of the water. So essentially, the important thing here is that 1 mole of copper sulfate gives me 1 mole of pentahydrate form. The whole thing gives me 1 mole of copper sulfate aqueous. And also, you should relate that aqueous state to this equation, that copper sulfate aqueous, since it is soluble and it's an ionic compound, it dissociates into copper ion aqueous and sulfate ion aqueous. So remember, we had made a we put 10 moles of copper sulfate into a quantity of 5 liters of solution, and we had a 2 molar solution. And now we can say that this solution that we prepared is 2 molar. So 2 molar is written as 2 moles per liter, or we just simply abbreviate it as capital M. Capital M refers to molarity. So I'll write it down, since I don't think I wrote that down yet for you. M is molarity. And this molarity essentially means moles of solute over liters of solution. Now, looking at the equation that I just gave you, the one above this definition of molarity, you can see that the relationship is 1 mole of copper sulfate to 1 mole of copper to 1 mole of sulfate. So if you have a solution that is 2 molarity in copper sulfate, you're going to get a solution that is 2 molarity in copper ion and 2 molarity in sulfate ion, because copper sulfate dissociates into copper and sulfate. So you can write it as molarity of, use brackets for molarity. Molarity of copper ion is 2. Let's just put capital M. Molarity of sulfate ions is equal to 2. And if you were to just say molarity of ions, this is the total molarity of ions, is 4, because you have 4 moles of ions, 2 of which are copper, 2 of which are sulfate, in 1 liter of solution. So you need to relate, in this exercise, I taught you how to relate the mole quantity to gram, and how to deal with the solute copper sulfate and find its mass. And we wanted to make a 10 molar solution. Molar means 10 molarity. Let's write that here too. So the word molar is the same thing as molarity, and same thing as the capital M. And for that, in order to achieve that, we weighed 2,500 grams of copper sulfate. We added it to our flask. We added enough water to fill it up to 5 liters. And of course, we have to, I'm not showing you the entire process. We have to cover the flask and mix the contents and make sure that all the copper sulfate dissolves. And once you have a homogeneous solution, you have a 2 molar copper sulfate solution. So this is basically teaching you how to deal with the compound, the mole concept, and solution preparation. And so that's part 1. So in the second part, I'm going to show you how to deal with some problem solving using this technique or molarity type of problems. Okay, so please review this video and make sure that you're good with that, and then watch the next video.